Welcome to another video in the Timco Retail Manager course. This course focuses on real-world application development. This is a series, so the way to get the most out of it is to start at the beginning and watch through in order. There's a playlist set up for that. However, if you're just interested in the topic this video covers, that's fine too. Think of this series like a bunch of Lego bricks. Each is valuable on their own, but seeing them put together is even more valuable. Now in this video, we're going to continue working on our WPF user interface by adding in dependency injection. Now if you're a Patreon supporter at the $5 per month level or higher, make sure you head over to get the latest source code. And let's get started. Now normally, when I do dependency injection, I use a tool called AutoFac. And I find that AutoFac is really powerful and yet simple to use. But with Caliburn Micro, it already brings in with it a dependency injection system called Simple Container. So instead of trying to force AutoFac onto this or get another plugin and try to make it work, I'm going to use Simple Container because Simple Container is simple and it does everything I need it to do. And I don't want to go as far as to go to the next level of Caliburn Micro, which is actually MEF, which allows for some pretty cool stuff, but it gets a lot more complicated. So we're going to stick with Simple Container for now. If we have to, later we'll swap it out, but I think this will be all we really need. So wire this up. It's fairly simple. As the name implies, private simple container, we'll call it container, equals new simple container. So this will be our container, which if you're not familiar with dependency injection, what it's going to do is it's going to handle the instantiation of all of our classes, or most of them. And this is actually a point some people get confused on, in that they think that once you have dependency injection, you can never new up an instance. That's not really true. There are times, especially the biggest one is data models. So if you have, say, Dapper loading data from a database, I don't go to dependency injection and say, give me a new instance for every row in the table. I just give Dapper the actual model. And yes, that creates a dependency, but I'm already depending on that. I'm not going to swap that data container out for a different data container, especially since I don't put logic in my data containers. So we'll see a little bit more of that later on. But just know that there are exceptions to the everything gets newed up through your container. Okay? So this container, though, is going to do most of the work where you'd normally see equals new something. Like right here. That instantiation, that won't happen very often in our application from now on, because the container will do it for us. So now we need to override a few different things. So let's go protected, override, and say get instance. And in here, we're going to say return container.getInstance service key. What this does is, serve is. What this does is when they pass in a type and a name, we go ahead and get that instance. Well, in this case, we're going to say, let's get it from a container instead. So normally Caliburn Micro uses the conventions, finds the location, and creates the new instance of, for example, the shell view model. Well, instead, we're going to use a container to get that shell view model. We also need to override, so protected, override, and this is get all instances. And in here, we need to return what it's doing and understand why it's doing it, because whenever you have magic sections of code and they break, you're up a creek because you don't understand the magic in the first place, so you can't fix the magic when it's broken. So I do recommend you understand it, but this really isn't something you're going to have to spend a lot of time on or do a lot of configuration for. So those are the 4 kind of simple ones for our setup. But we have one more, and this is the one that maybe you're looking at this and saying, well, where does the actual instantiation happen? Or where does the container know what to connect to what? And that's where we have the configure method. And I actually usually put this right below the constructor because this is the most important one, I think. And so it's what I want to see right up front. So protected, override, and this is the configure method. And here, what we do is we say container.instance underscore container. What that's going to do is whenever you ask for a simple container instance, it'll return this instance to you. So it's kind of a little bit meta here. The container holds an instance of itself to pass out when people ask for a simple container. The reason for that is because we may want to get this container in order to manipulate something or change something or to get information out of it besides from our constructor. So that's the start. Next, there's a couple of things that we need to add that are based in Calibre and Micro that we're going to use. So container dot, and this is the format I've seen Calibre and Micro do, and so I'm going to do the same because it kind of makes sense and it also helps it be a little bit more readable. So I'm going to hit enter and then do dot down here. Now for C#, it doesn't care. If you have this line break here, no big deal. All it cares about is where's my semicolon. That denotes the end of a line. So as long as you wait to put the semicolon, it's cool. We'll just keep, multiple lines. So singleton, window manager is window manager. And open, close parens. And then I hit enter and dot singleton, event aggregator is event aggregator. So what is this doing? Well, there's 2 different things that Calibre and Micro uses that I want. And there may be more later, but for now, these are the 2 that stuck out to me as important from all the extra stuff Calibre and Micro gives us. The first one is the window manager. So handling the idea of bringing windows in and out. That's pretty important. And the other one is the event aggregator. So this is where we can pass event messaging throughout our application. So one piece can raise an event and a different piece can listen for it and do something with that event. Essentially, that's how we tie our application together instead of passing data back and forth through constructors and public methods. So we have an event aggregator that handles it for us, a central clearinghouse for all events. So those 2 things I want to come through, but for both of these, they're singletons. Now, if you're not familiar with singleton, what it is we create one instance of the class for the life of the application, or in this case, for the scope of this container, which is the same thing as the entire application. But what that does is then if the shell view model asks for an event aggregator, let's say, it's going to get back the first event aggregator ever created. If a different view model asks for an event aggregator, that view model is going to get the same event aggregator as shell view model, because we only have one instance for our application. That's a singleton. It's almost like a static class, but not quite. So and the reason for that is, think about it this way. We're going to connect to events. Would it make sense to have different instances with different events in them and then have this thing where basically no one's talking to each other because your event that you want is in one instance and the event that you subscribe to is in a different instance, and so they never talk to each other? It'd just be a mess. So one central clearinghouse, one event aggregator, and everybody connects to it. Same with Window Manager. We don't want Windows open in 5 different instances and not displaying because it's not in the right instance. So you have one instance. So those are singletons. Typically, your application should be very careful not to use singletons unless you know for sure you should. It's one of those design patterns that people often want me to teach on, and I'm going to at some point. But the danger about a singleton is when you learn about it, you want to use it. And really the best advice is don't use it unless you can't find a better way and work really hard first. Because singletons aren't typically great on memory usage, and they're not great on the overall using object-oriented the way it's supposed to be used. So just that note of caution, don't make everything a singleton. In general, you want to be per request, which is basically a new instance each time. Create the instance, use the instance, throw it away. Okay, so now we have our 2 events, or our 2 interfaces registered. So the first one's the interface. This is what we'll ask for. We'll ask for an iWindow Manager. And when we do, we'll get whatever this instance creates. So a new window manager, a new event aggregator for iEvent aggregator. This ties the interface to the implementation. Now we need to handle one more big set, and that is all of our view models that connect to our views. How do you wire those up? Well, we use a little bit of reflection, which, if you're familiar with reflection, it's one of those tools that's really powerful, and we say almost always don't use it because it's slow. And slow is a relative term. It's not slow like if you do it once, you'll see a noticeable difference. But if you do it 10,000 times, sure, you'll see a difference. It's kind of like adding strings together. It's just fine to add strings together, but if you're going to do it 10,000 times, don't. Use a string builder instead. So in this case, we're going to use reflection, but this configure gets run once at the beginning of the application. So there is a small performance hit on startup. But when I say small, it's tiny. And it happens once and not again. So we're not going to worry about this performance hit. This is a good use of reflection. So we're going to say get type dot assembly dot get types. I'm going to come down to the next line because it's going to get long. Dot where type, and the arrow function or the lambda expression, type.is class. So we're going to go over this statement when I'm done typing. I want to kind of go through it first and type it out. Dot where type, our arrow function again, type.name dot ends with view model. You see where we're going here? Dot to, let's do this next line. Dot to list. Dot for each. View model type, our arrow function, underscore container dot register per request. So every time you ask for it, it's going to give us a new instance. Open our parens, and inside here we're going to say view model type, comma, view model type dot toString, and view model type. The very end, a semicolon. So what did I do? Well, I said we're going to use the reflection get type for our current instance. So it says, okay, let me say the current assembly that's running. Get all the types. So it's going to say get everything, every type in our entire application. And we say, well, actually, we're going to limit that, which is the where clause here, kind of like in SQL, and say only where a type is a class. It's only the class types. But we're going to limit it further and say where the type of the name of the class, so the name of this class ends with view model. Sound familiar? That's this right here, shell view model. All of our view models end in view model. That makes it very, very easy then to say, well, give us all the classes that end in view model. When they do, take that list and print out or create a list. This returns a IEnumerable, which we can't use a for each on. But toList helps us because now we can do work on this list, particularly the for each. So we're going to do a for each on every class that we found that ends in view model. In this case, only one of them. But in the future, there'll be more, and it's going to automatically add more because it finds everything with view model. So it's going to say, okay, I want you to take my container and register per request. So this is for each. So when it finds shell view model, it's going to bring it in here. Say container.register per request, shell view model's name, and then shell view model again. And that's the format of type, key, type. And it's service and implementation. So the idea here is if we wanted to, we could have the first one be our interface, like this one is, and the second one be our implementation. But we're not going to do that for our view models. We're not going to create interfaces just to create interfaces. So instead, what we'll do is we'll just have it wire up the actual class, the view models. Now, yes, this may make it a little bit harder to unit test, in which case we may come back here and change this over to an interface. But for starting out, I think that wiring directly to our class type is fine. So we'll start there. We can expand more right to a unit testing and say, yeah, we need to do that. We can go ahead and create interfaces and wire to that. So I'm planning for the future, and I'm planning for the fact that this will change at some point, but no worries because that's just changing this code right here. It's not really changing a lot other than adding the interfaces as well for our view models. And so I can look to the future and say, I want to do that, but I'm not unit testing now. So there's not really a need for me to do all this extra work just to get off the ground when I'm not going to use it now. And it's not a big change later, so I'll leave it for later if I need it. So I'm trying not to over-engineer this to the point where it takes weeks to get an application ready to start. We're trying to get it started. So that's what we're going to do. We're going to just go ahead and wire it up just based off the type itself. So that being said, we need to make sure this works because we just changed a whole lot. We actually added a dependency injection system that's kind of built into Caliburn Micro, but we configured it and we're not quite sure, is it going to work the way we expect it to? Is there bugs or problems? Let's find out. Let's hit start. And it started. Now notice that startup process didn't take any longer than previous times. So it's not like we have anything big going on yet. Now we don't have a whole lot of shell view models and other view models to search through. But reflection didn't take an awful lot. Let's put it that way. So it still runs and it seems like nothing else has changed. So here's what we're going to do. I'm actually at this point going to commit my code because I have working code that I believe is correct. So I come here and go to synchronize, go to changes, and there's a lot to have that's changed. Let's just review it, make sure that we know what's going on. We've added basically everything in the desktop UI project and also the solution. That sounds about right. But let's make sure that all the files we've added are correct. And they appear to be. I don't see anything here that stands out to me as not in the right place or not the right file to add. So let's go ahead and add all of these. We're going to right click and say stage. And now we're going to say add WPF project with MVVM. Adds our WPF user interface project and configures it with Caliburn we can zoom in here. There is a red circle with a line through it next to our trm data.publish.xml file. And you may wonder what that is. That's Git telling us that it's ignoring this file. And the reason why is because we don't typically want to publish settings. We don't want to put those into GitHub because those might contain sensitive information like usernames and passwords. So just know that's not getting pushed up by default, and I'm okay with that. That means I can use it locally, but when you pull it down from GitHub, if we're going to do that, then you would get an empty, actually wouldn't even get this published locations folder. So then you could create your own published locations folder, put your own published profiles in there, and I wouldn't get them because I'm not publishing to your SQL server. You're not publishing to mine. Therefore, it's a good thing we're not sharing. So just kind of note that when you're looking through and reviewing your files, do look at those icons to tell you what's going on. Okay, so now we have this committed and we have no changes left. Let's make sure that's correct. Yep, no changes. Now I'm going to make a change that I don't want to keep. I want to try something out, and I know I'm not going to keep the code. I just want to make sure that my dependency injection is actually working correctly. So what I'm going to do is create a class. I'm going to put it into dependency injection. I may even create an interface for it. And then I'm going to ask for it in the shell view model. Okay? So all this code is just dummy code to make sure that dependency injection truly is working the way I intend it to. I don't want to keep the code. But with Git, I don't have to worry. I've committed my latest change. and say extract interface. And just hit OK for the defaults, which are going to be fine for me. Just it checks all the public methods and properties, calls it by the name of the class with an I in front of it, and puts it in the same folder, which is cool. So now I have an interface I calculations that has my register and my add, and now calculation implements I calculations. So cool. I have something to work with. Now I can come over to my bootstrapper.cs, come right down here, and I'm going to want one instance per request. So let's say container dot per request. So it's going to get one per request. I'm going to say I calculations. So what this is going to do is going to register my I calculations interface as what will be asked for. And when that's asked for, it returns calculations, this instance per request. Therefore, if you request in 5 different view models the I calculations, you get 5 different instances of the calculations class. Now, in my shell view model, let's create a private I calculations, call it calculations. I'll create a constructor, CTOR, that's going to ask for an I calculation, call it calculations, no underscore, and then say that underscore calculations equals calculations. So what's going to happen is shell view model is saying, I want you to give me, when you create me, I want you to give me an I calculations instance. So whatever implements I calculation, give that to me, a new instance of it, and put it in this variable, this parameter. We're going to take that parameter and store it in a private variable on this instance called underscore calculations. In theory, that's all we have to do. Register our instance and our interface that it talks about it, and then bring it in a constructor. So I'm going to put a breakpoint right here. I'm going to save everything. I'm going to run this. And when it starts up, it's going to pause at this breakpoint, because remember, this is the start of our application, is the shell view model. So let's look at the calculations parameter. And if we zoom in here, it says calculations register count equals 0. So what is that saying? Well, it's saying it only has one property called register. And that property has 0 items in it. So that is our instance of, in this case, trm desktop UI.calculations. So it's created an instance for us and passed it into our shell view model. So we're all good. Our dependency injection system is just that simple. Whenever we create a new class we want to add, we just register it here and tell it either singleton or per request. And then we also just ask for it then in our constructor. That's it. So now we have a sample code in, it's working, that's great, but I want to revert all of this. And it used to be that you'd have to go ahead and delete different things, but notice up here, my project changed. Do you know how to revert the project? Well, you don't have to, thankfully, because we're using Git. So instead of deleting things and trying to manually back things out, go over to Team Explorer. Notice there are 5 files that have changed. We've updated shell view model, we've updated Bootstrapper, and we've added calculations and I calculations. and we've updated our project. But if you highlight the files that you want to undo the changes in, right-click and say Undo Changes. It's going to say, are you sure? Because you're going to basically delete these 2 ads, and you're going to delete the changes in the other 3. Yep, that's what I want to do. Do that, and now there's 2 more files. Those are the ads. It doesn't undo them because there's nothing to undo them to. But what we can do is say delete. Since they're add, we can delete them. And say, are you really sure? We say yes. Now there's no more changes. It's just like it was before I started testing. I've wiped out all my changes. Now I could have gone, create a branch, done my work, checked back into master, deleted the branch, and that works as well. But again, I'm simulating a small environment, just me. So doing that little bit of stuff, not a big deal. But if I was going to do some work to be a little bit longer, yes, I'd create a branch first and then do my work. Then check out the branch and either delete the branch or leave it sit there just as a reminder in case I have to go back to it. But for now, that's it. We're done. So we have created our WPF application. We've added MVVM with Caliburn Micro, and we have wired it all up. And we've also made sure we wired up our simple container system for dependency injection. In our next video, we will set up our class libraries so we have a place to put our data access layers. For now, thanks for watching, and as always, I am Tim Corey.